everyone, welcome back to Dragonfly Engineering. So this week we are going to unbox a new, to me, or used and bought on eBay, KUKA robot. This is a small 6-axis one. I think it's the smallest one they make. We're also going to check out the hot glue gun system, which is another new acquisition for some of my day work, as well as making boxes, hopefully for products that I'm shipping direct to Amazon. So that we will check out next, and the idea is that this new robot is going to work with the hot glue gun to dispense out beads of adhesive to assemble parts together autonomously. So let's take the lid off of this. I've already unscrewed the top, and I checked it out when UPS came, and I've got a little footage of that as well. I didn't see any forklift holes. This hole was, I don't know if you can, there's a hole down there, but it's a drilled hole. But usually when you receive a crate from a freight company, you want to look for long, skinny slits in the bottom of the crate, which usually means a forklift driver used your crate to push something else around. And sometimes their forklift tine will actually pierce through your crate. I didn't see any of that, but I did see one problem. The thing that concerned me is there's footprints on the top of this crate. And when I took the lid off, yeah, actually, so you can probably see footprints right here, and that corresponds exactly to where the top of the robot was flush with the crate. So that's a bit of a concern because there's no support across this crate. The crate is in pretty good shape. I mean, 2x4s were used, and then, you know, the controller is strapped down and the robot is bolted to the base, but someone put their foot right on the top of this robot. And I've already taken this off and checked out the robot, and I did see that axis, what is it, number 2, which is this axis, and axis number 3, oh no, this is axis number 2. Axis number 3, when I turned on this robot to make sure it worked, because I wanted to basically get back to the seller, these two axes were not mastered. And what that means is when you power off a robot, the controller in the robot arm itself down in this housing records where the actual rotational position of each axis of the robot is. And then when you power up the robot next time, if the position of this axis is different than what the controller in the robot remembered it was when powered off, then it tells you you need to remaster the robot. And I got that on this one. So whoever stood on my crate basically pushed down on the robot when it was powered off and actually moved this axis and moved this axis. It's not a big deal because you just remaster the robot. This robot, I think, came out of probably a failed assembly line in some factory somewhere, because I have another robot that has the same color scheme, and again, this was purchased on eBay. And I didn't go and check it in person, even though in the past I recommended that if you buy a robot on eBay, that you need to go in person and check it out. But this company was actually an incorporated company, and the fact that I have experience with this kind of repurposed KUKA robot that someone had colored special, I took the chance and I did not actually go to check this robot out in person. And looking at the teach pendant, there's not a mark on it. So I think this robot was probably never used other than just to bolt it on a factory line and then take it out when whatever didn't work out with whoever owned it before. So I'm going to plug that into the power port. And this is the temporary emergency stop shunt circuit and a DB50 connector on the front. And these breakout boards are real nice. You can buy these on Amazon. Right into the connector here on the controller, like that. Maybe you can see that when I flip this on, these all turn green over here. So now I can actually move carefully, because the robot's still inside of the box, some axes. So we're going to move axis 3 up, like so. And before this didn't work because the controller said you must master axis 3. And I'll show you what that means here in a second. So we're going to move axis 3 up, and we're in an axis mode as opposed to XYZ translation mode. And now we're going to move axis 2 just so we can kind of get out of the crate a little bit. And that looks good. Yeah, so here we're looking at the axis 3, and what you do is you unscrew this cap right here. And you do have to customize a dial indicator or buy one from KUKA. But you unscrew the cap, and then you can install a depth indicator into a little steel plunger here that has a point on this side, which I don't know, you can probably see that. And this point, basically when it's sitting in the center of this little micro V in that steel stud right there, that means you're zeroed. But what we're doing is we're checking to make sure that our robot can travel in a straight line in X, Y, and Z with fixed angles on the end effector. And we're holding a pretty straight line there, so that's good to see. And then we'll do Z as much as we can. All right, so it looks like it knows how to move itself, so that's nice to see. We can do a little bit with the angles. The center point of the flange right now is I assume to be its center, that it knows it as what the tool position is. All right, so the next thing we're going to do is basically uncrate this robot, and we'll put it on the pool table converted to a workbench to try out the integration of this robot to the hot glue gun system, which I'm going to show you next. All right, so the second half of our robot work cell that we're going to be working on for this episode and unboxing is the automated hot glue gun dispenser, which is inside this box. And it's made by Astro Packaging, which is what seems to be a family-owned business in Southern California. And I believe it's all made in the USA, but I'll have to confirm that. And they're not a sponsor. I bought this basically full price. I just found them on the internet and needed it, so I bought it. But they were, yeah, real helpful to work with. So yeah, I'm gonna give them a plug just because they were nice people to work with and pretty straightforward. All right, so I'm gonna lift off the top of the box here. I've already unscrewed the bottom, and we'll see what the hot glue gun dispensing system looks like. All right, so here it is. This box at the top, I believe, is full of hot glue gun pellets. Whereas if the hot glue gun you get from a hardware store or a arts and crafts store, the hot glue comes in sticks, cylinders that you stick in the back of like a pistol grip. In this case, the hot glue for an industrial purpose comes in pellet forms. And a automated hot glue gun dispenser dispenses out, I think, a half a millimeter, I'll have to look it up. I think it's a 20 thousandths or half a millimeter orifice that dispenses glue pretty rapidly and also very precisely with the inputs from the robot. So every time the robot gives this thing 24 volts, it's dispensing glue. And as soon as it stops giving 24 volts, it instantly stops dispensing glue. So it's used a lot for cardboard packaging and electronic assembly and things like that. And then below here is the heated vat, so this door opens. Oh, and they've got some hot glue in there already, so they tested this at the facility. All right, so looking down into our vat here, it seems like the pellets are much larger than what I anticipated. They're almost like packets, maybe 1 inch by 2 inch. So this system heats up this hot glue inside of this vat, and it also has this heated hose here. So this entire hose is the same temperature as the vat to keep the hot glue in a liquid form. And then under this unit, there's like probably a 1/2 horsepower motor and pump that pumps and pressurizes the line all the way up to this nozzle here. So whenever the nozzle sees voltage, it opens and then the pressurized hot glue squirts out onto your substrate that you're gluing onto something else, or your cardboard box flat form that then you bend up into a nice, cardboard box for shipping your product. So I'm going to use this for both product assembly as well as box folding and gluing with the robot. So it should be pretty fun and kind of a relatively universal tool. And then there's endless amounts of different type of hot glue that you can use for various applications. My understanding is that you can get several different third-party dispensing heads that fit onto the Astro Packaging like glue dispensing system. So this actually isn't made by Astro Packaging, but they sourced it, and it's a Dynatech microbead hot glue dispense nozzle. So they basically, Astro Packaging incorporated this third-party nozzle onto their system. These are a little heavy, mostly cast aluminum, I believe. So normally this robot would be mounted to a rigid steel or aluminum table, so the table can absorb the inertia that's created by these big axis arms moving at 2 meters per second acceleration. There was some configuration in this controller which worked with whatever system it was working with, but I do very basic projects or configurations of the controller. So I reset the controller back to the factory settings, basically, for lack of a better word. But when I did that, I did have to go into the software that KUKA has to configure these robots to map the inputs and the outputs from the EtherCAT connection. So if we look at the controller, you can see I've got a pin on pin number 17, which corresponds to the first output of the robot. So when I flip the output on and off, as you can see on this screen here, I've got output 1 is on, which corresponds to pin 17 of this X12 connector. You can see that one green dot is output 1 is on. So when I probe the voltage on the voltmeter here, which is tied to ground of our external 24 volt power supply over here, you can see we've got 24 volts. So now if I turn that output off and I turn off the output, you can see now we've got basically, well, 180 millivolts, so basically 0 volts. And you see that green LED that was lit up is now off. So that was all done by me basically configuring or mapping the inputs and outputs of this Beckhoff I/O module, which is basically an array of relays and voltage sensors. So there's 16 inputs and 16 outputs, and it reads 16 24 volt input signals and it sends out 24. Anyway, so, but I had to configure that, and KUKA doesn't do that automatically. You actually have to download this visual or work visual, and then you got to say, okay, input 1 is connected to channel 1 of the Beckhoff EtherCAT module. So anyway, you got to do that. If you actually want to have your robot controller control anything, then you got to go through this sequence. And basically you got to take a class from KUKA or call up KUKA and bug the tech support until they walk you through the process. Now we can turn 16 things on and off and read inputs from 16 other things. Okay, so I think we got all of our configurations ready, and our system is kind of ready to go to do some trial runs with the robot. We can start with the claw, which is spring return, to an 1/8 inch air line, which then travels through the body of the robot, comes out the back here, and that way you don't have to deal with stringing air lines and getting all tangled in the robot as it moves around. So we got the air line here, which goes over to this valve, which is then keyed into the pressure line, which goes off to the air compressor. This valve, when it's actuated, will close the gripper. And then over here for our heated nozzle unit and reservoir, I've got the reservoir heating up, and it's, according to the instructions, it takes about half an hour for this thing to heat up. And we've got the, the hot melt tablets in there that are remelting in the tank. And we got the power on, and then we're going to flip the pump on. So the tank is heating, the hose is heating, and it does it sequentially. So you can see the tank is heating up faster, then the hose starts heating, and then finally the gun starts heating. And the gun's not really started to heat yet, but half an hour later everything will be heated up. And they do it that way because the most thermal mass is in the tank, so they start the tank heating first. And that way they can time the 3 heat up times such that when you're ready to go, they all are ready and hot at the same time. Over here we got our 2 lines. The blue line is for the gripper, and the brown line is for this valve, which is on the hot nozzle to open and close the gate for hot glue to squirt out. So this is the home position. This is the first position in the program and the last position in the program. And my understanding is the robot needs to go back to home so it can kind of reset or make sure that its coordinates are all refreshed and exact, and then it'll do the same sequence over and over again, or at least to the extent that I program these robots. Oh, I also have the Gopro Robot Cam. I mounted this GoPro to the wrist or to the elbow of the robot so it can check out what's going on. All right, so here's our hot nozzle tip. This is our gripper. This is the little temporary stage that I made, which is an old mold that I made a while ago, and which is now going to be our reference fixture for setting the location of the part we're going to pick up. We're going to glue it, we're going to flip it over, and we're going to squish it down onto this part using the robot and the gripper. And then we got a stack of extra parts here. So now that we're at the home position, I am going to teach the robot, and we can start the GoPro here, to come down to grip this part. So it should be fairly simple. We're going to move down in the Z axis, and it looks like I need to rotate the end effector so that the corner of the robot doesn't hit our fixture plate here. And I can go ahead and teach this position. I like to do linear motions. We're going to do 1 meter per second just to keep things under control. And something called continuous. So I'm teaching this first motion point, so the robot's going to come and hit this point. But with the continuous, what it'll do is it'll actually round off the corner, so it has more of a fluid motion, so there's not such a jerky start and stop going on, but more of like kind of organic flow of the robot action. So anyway, that's the prompt, and I'm going to hit Command OK. So we just set our first point. Now we're going to move in, and I always get the direction backwards no matter what. And I'm going to set the pounce position, and the pounce is basically where you set your robot close to where it's about to do some action. And you can probably see some shaking of the robot because it's, again, mounted on this temporary wooden pallet, which is by no means ideal. Now I also like to do things like put a little wait command just so things can settle, especially since we're on this wooden pallet. And we'll say 0.2 seconds. And then we'll say, okay, that's a good command. So the next thing we're going to do is turn on the output to output 1, which actually closes the gripper. Oh, actually output 1 is the, oh, I got to turn on the, I have the compressed air off. There it goes. So there it gripped it when I turned on the air. Okay, so now that we've got the gripper gripping and output 1 is on, our next step is to bring the coupon up to the hot glue nozzle. I should probably put safety glasses on since we're going to be squirting hot glue. So let me do that. Okay, so now that we're holding onto our part, I'm going to go Z positive. At least I don't mess that axis up. So we'll come up in Z. You can see the wiggle of the table. And we're going to teach this point. So if I actually went over and had the robot bring the part over to the nozzle, it would try to do a straight line and maybe hit the corner of this block. So I'm going to do a motion, linear, and that will be continuous, Command OK, 1 meter per second. Okay, and now we're going to move the part in. Whoops. Actually, I got to probably adjust Y anyway. We're going to do a simple square pattern, I think, instead of a more complicated circle. Because why do we have to fuss with that? Because I'm going to have to redo all of this when we move the robot into the actual workspace that it's going to be working in. So I am going to hit the play button, and we're going to go back to the home position and then play the program that we just started to write. Okay, so we're going to hit the play, and we go back to the home position. And now every time if I hold down this play button, it'll run us through the sequence of events that we've already programmed into our nozzle. So come down to the first. Oh, well, here we're going to pick up the part, like so, even though the gripper's already got it in his hand. We're going to come over, and we're going to turn on the output. Oh, and it squirted glue and shut it off. That was a little fast. So this will be a little bit of trial and error. I may time-lapse this effort. Alrighty, so now we're going to bring the part down and effectively just glue it right on there. We'll flip on the pump, and I am going to pull the trigger, and here we go. And we're running at 50% robot program speed. All right, that was a little better. There's still like a blob at the beginning. So, this is where I'm going to have to start playing with lead in and lead out velocities. So, let's try again. So over the next, hour or two, I can start playing with how to eliminate that starting and ending blob. One thing would be to not have the bead go back to the original position, but actually allocate for some of the flow in from the start to finish. Or I can increase the robot playback speed too. Let's go to 75%. So far it looks like the crate can hold the robot's velocity. All right, so I'm gonna hit reset. And one more time, let's fire this thing off. Oh, that's better. You can start to see how the robot was shaking because of the wooden foundation it's sitting on. All right, so let's take a look at this one. This is a little better. This blob here is what I have to program out, but the rest of the line looks reasonably good. So I think that's good first kind of proof of concept for this system. Let me turn the pump off. So what we're gonna do next, in the next week or so, is to build a big robot workstation. Let me zoom out. Well, I think we've proven that this system is going to work out for production. The robot seems to be fully functional, and the Astro Packaging hot glue dispense system actually works great. In fact, it works a little too good when I discovered that pump can really pump out the glue. I'm going to have to figure out how to minimize the start and the stop volume of glue, so that basically as the glue in the robot initiate the gluing profile, half of the glue needs to start at the very beginning, and then we need a full bead of glue. And at the very end, as we meet up with the beginning, we need to go back to half amount of glue again, so that that little start and stop point equals the amount of glue that's in the rest of the profile that we're drawing out on a part. So that's just going to be fussy robot programming, which can't really happen on this table because as we speed up the robot, everything starts to wobble and it messes up our glue pattern anyway. So to fix that, I purchased a large sheet of aluminum, 3 by 4 feet, which is like 1 by 1.3 meters by 3/4 of an inch, or approximately 20 millimeters thick. And we're going to, or I am going to build a robot work cell out of this big slab of Mike 6 cast aluminum with a steel substructure to get a lot of rigidity and weight. And 2 of these robots are going to be sitting in opposite corners, as well as the Astro Packaging hot glue system with a fixture so that we can assemble parts and glue them together and then send them on down to the next robot work cell. So that's coming up shortly, actually. I've got the slab of aluminum in the back already and the steel, so I need to cut and weld and build this system, probably fill it with sand so we get a nice solid base so that we don't get the wobble that we get when the robot's really working. And I'm going to do a quick walk around, one last review of the hot melt system. So each one of these components, you set a temperature for the hot melt. So 350 Fahrenheit for the tank, and the hose is 350 as well, and then the nozzle is 360 degrees Fahrenheit. And then down here, if you want to pressurize this system to deposit the hot melt, then we flip on the pump switch, and then there's an electric motor down here which is turning a breakaway shaft coupler to a hydraulic pump, which is pumping the hot melt and pressurizing this line here. So as we turn on the output to the nozzle itself, I'm going to turn on the valve, which I've zoomed in here, and you'll see how the hot melt shoots out and stops pretty repeatably as we turn off the nozzle. So we can have real short bursts, as fast as I can hit it on the robot controller, or long continuous bursts to draw out an intricate pattern, and then we stop it again. And yeah, so you can actually draw out pretty complex shapes with this hot melt and then glue it onto your other part. So that's pretty cool. I'm going to turn off the pump, and then we'll walk around, check out the side of the unit. So like I mentioned, this knob in the back here is the flow control, which is the output of the pump, and that allows you to increase or decrease the amount of hot melt that is being squirted out of the nozzle. And then up here at the top of the unit is the tank with the hot melt glue in it, and you can probably just see the remnants of some of the original pellets, which were larger than I thought. They're like about a square inch or so. Anyway, so that's the Astro Packaging system. Here's the information if you want to reach out and get your own automatic glue dispensing system. Pretty nice. I'd have to recommend them. So thanks for watching this week, and if you'd like to support this channel, you can check me out on Patreon. The details are at the end of the show, and also please like and subscribe to the YouTube channel Dragonfly Engineering. Thanks for watching, and I'll see you guys in about a week. Have a good week. Bye-bye.